All right, lecture 32, inverse variation. So last time we met, we were talking about direct variation. So the first point I wanted to make is there are two types of variation. Two types of variation. The first one is called direct variation. Direct variation. The second type is called inverse variation. Inverse variation. So we'll be talking about both today, but more on the inverse variation. So these two types of variation, they're modeled by different types of equations. So the direct variation is going to be modeled by the equation y equals k times x, where k cannot be equal to 0, because then you would just have y equals 0, right? So that's direct variation. That's the formula for it. It's important to understand that x and y are both variables. They are both variables. While k is a constant. K is a constant. So that means k is just going to be a number, like 3 or 4 or -5. That's direct variation, y equals k times x. The only restriction is k cannot equal 0. So inverse variation is a lot like that. It still has x and y. It still has k too, but it's going to be written in a different way. So the equation for inverse variation is going to be y equals k divided by x. K divided by x, where x cannot equal 0. Because if x really was 0, you would be dividing by 0 at that point, and we don't want to do that. X and y are still going to be variables. K is going to be the constant. All right, so let's talk about k a little bit more. We know that k is just going to be a number, but k is often called the constant of variation. The constant of variation. Otherwise known as the constant of proportionality. Proportionality. And that just means that k is the proportions between x and y. So k is often going to be called the constant of variation, or it's going to be called the constant of proportionality. So I'll put a star beside that. So x is a variable, y is a variable, but k is a constant. So it's just going to be a number. Okay, so next thing I want to do is I want to talk about inverse variation a little bit more in depth, how it works, what are some examples of it, and how you graph it. So let's take a look at the next slide. So inverse variation leads to a relationship between x and y. So we can say that the product of x and y stays the same. The product of x and y stays the same. And this is because if you were to start off with the inverse variation, y equals k over x, then what you could do with this formula is you could multiply both sides by x. So let's say I was to erase this arrow and I multiply both sides by x. So I'm going to have an x over here, I'm going to have an x over here. And what's going to happen is these two x's that you see on the right side are going to cancel each other out. So these are gone. And you're only left with k. on the right side. And on the left side, you have x times y. So you get x times y equals k. So that's why it's important to say that the product of x and y, those two variables, is going to stay the same throughout the entire problem. And that product of x and y is going to be k. Okay, so the product of x and y stays the same. Another thing we can say is if x increases, then y is going to decrease. So y decreases. This is an inverse relationship. So if x is going up in value, at the same time, that must mean that y is going down in value. So that's called an inverse variation or an inverse relationship. Now, what we saw with direct variation last time was if x increases, y also increases. But when we're talking about inverse variation, we get that sort of opposite relationship between x and y. Even though when we multiply the two numbers, we still get to k. So if x increases, y is going to decrease, and vice versa, right? If x decreases, then y is going to increase. Y increases. So what that means is if x goes down in value, then y is going to go up in value. There's that inverse relationship between x and y. That's important. All right, and the last thing we'll talk about is the graph of the function. So the graph of the function is going to be a hyperbola. So what does this look like? Well, suppose k equals 1. Then y equals k over x becomes y equals 1 over x. So when I graph 1 over x, I'm going to get this graph right here where I have a y-axis and an x-axis, sort of like this. So when I graph this function on the xy plane, I'm going to get a graph that looks like this. It's going to kind of go like that. And then there's going to be a second curve in the third quadrant that's going to look like this. So in a minute, we'll hop up on Desmos and we'll graph it, and we'll see what it actually looks like when a computer graphs it. And it'll look a whole lot better than what I just showed you. Right? Okay, so what is a hyperbola? Well, let's go over to Desmos and let's graph y equals 1 over x. So let me go ahead and resize the window. Just give me a minute. Okay, perfect. All right, so we are at Desmos right now, and what we're doing is we want to graph the inverse variation formula. And the inverse variation is going to be y equals k over x. And k is going to allowed to be a constant. So right now, when we graph y equals k over x, we originally let k equal 1, so we get y equals 1 over x. And then notice what the graph is. It's going to have two U-shapes opposite from one another, pointing away from one another. And these two curves are in the first quadrant and the third quadrant of the xy plane. Now I'm going to go up here and I'm going to change the value of k. So like I said, k is just a number. You can let it be whatever you want it to be, I guess, except for 0. But what happens is when I hit this play button, the value of k is going to change. So watch this. So what I'm doing is I'm letting k be any number between -10 and +10. And what that's doing is it's showing you how the hyperbola takes its shape. So the hyperbola, it's always going to be two different U shapes. They're the same graph though. So the hyperbola is going to be two U shapes and they're going to be pointing opposite away from each other. And that's inverse variation. And I'll stop it at 1. So let's make it 1. Okay, so that's inverse variation. And you may remember from the last lecture that we were talking about direct variation. So the equation for direct variation is going to be k times x. So this is y equals k times x. And remember, x and y are variables, k is a constant, so k is just going to be some number. And let's see what happens to direct variation when I change k. And what it's doing is it's letting k vary between -10 and +10. So when k is very negative, you get this negative slope. But when k is positive like that, you would get a positive slope for your line. And if k is 0, let me show you what happens when k is 0, which you are not allowed to do. You get a horizontal line, which is actually the x-axis when I look at it. Okay. So hitting on back, let me resize my window again. There we go. And then there. Okay. So that's the graph for inverse variation. And you can see how that's different from direct variation, where direct variation is just a line, and inverse variation is going to be a hyperbola. So let's take a look at some examples and see how that works. So let me look at the problem set. I think I put 5 questions on the classwork. You can do that today, but I'm going to look at the practice set first. Okay, so on this problem set, let's look at number 1. Okay, so number 1 says, suppose there is inverse variation between x and y. Find k if x equals 2 and y equals 8. Let me fix that. There we go. Okay, suppose there is inverse variation. Inverse variation. So the first thing I do is, just like for direct variation, I want to write out the formula first. So the formula is going to be y equals k over x. So then the next thing I want to do is I want to plug in my givens. So they give me x equals 2 and y equals 8. So I'm going to plug those into the formula and I'm going to figure out what k is. So I'm going to replace y with an 8 and I'm going to replace x with a 2. That's all I'm doing. I'm plugging in my givens. And then I can get k by itself. I can do that by multiplying both sides by 2. So we're going to multiply both sides by 2. What that's going to do is that's going to cancel out the 2's on the right side. And on the left side, I have 2 times 8 equals 16. So 16 is equal to k. That's my answer. So we know that k is going to be 16. That's my constant of variation that I'm trying to find. Okay. I'll leave that up there for a little bit, and then we'll look at number 2. All right. Let's look at number 2. Okay. Assume y varies inversely as x. If x equals -3 and k equals 12, find y. There we go. Okay, so we're assuming that y is going to vary inversely as x. So the first thing I need to do is write down my inverse formula, which is y equals k over x. So that's my inverse variation. And it tells me that x equals -3 and k equals 12. Those are my given information, so I'm going to plug those in. I don't know what y is yet, so I'm going to leave that as y. It tells me that k equals 12, so I'm going to replace k with a 12. And then what am I dividing by? I'm dividing by -3. So x equals -3. I plug that in for x. And then 12 divided by -3 is -4. And I'm done. Y equals -4. So I'm setting up my formula. I'm plugging in my numbers, and then I'm going from there to whatever they ask me to find. And if you know 2 out of 3 letters, then you can find the third letter. No problem. Okay. Let's look at number 3. So 3 says, suppose inverse variation is modeled by y equals 3 over x. What is the constant of variation for this equation? Okay. So suppose we have inverse variation, and it's modeled by y equals 3 over x. So then what is the constant of variation for this equation? So whenever I do inverse variation, I write out my formula first, y equals k over x. And it's telling me that this inverse variation is modeled by y equals 3 over x. And then it asks me, what is the constant of variation? Which is just k, right? So it tells me in this problem, I have 3 on top. So that's going to be my k. K equals 3. So that's just kind of like a gimme, right? That's just asking, hey, do you know what the equation means? Do you know what k is? If you could find x or y, you could find those, of course, but you would need a second piece of information. So k equals 3. That would be the answer. Okay, we're going to do 2 more questions, and then we'll call it a day. All right, number 4. So number 4 says, assume y varies inversely as x. if k equals 9, find x when y is equal to -1. All right, so we're assuming that y is varying inversely as x. So I get my inverse equation ready, y equals k over x, where k is just some number. Now it tells me that k equals 9 and y equals -1. So those are the variables that I'm going to plug in. I know that y is -1, I know that k is 9, and x is unknown, right? That's what I want to solve for. I want to solve for x. So to do that, what would I do? 9 divided by what equals -1? Well, -9, right? So that's what x would be. That's one way you could think about it. Another way that you could think about it is if I was to erase this question mark and I think, how do I usually get rid of stuff when I'm doing algebra? I'm either adding, subtracting, or multiplying or dividing, right? So since I'm dividing by x, I'm going to multiply both sides by x. Multiply both sides by x. I'll put this -1 in parentheses so it doesn't get confused. So if you're multiplying both sides by x, what happens? Well, x times -1 is going to give you -x. I still have 9 on top, but what happens to the x's? They cancel out on the right side. And that just leaves me with -x equals 9. Okay, so we're almost there. I just need to get x by itself. Now, one thing is standing in the way of this, it's that negative sign. But I can get rid of that by dividing by -1 or multiplying by -1. But you got to do it to both sides. So we're going to divide both sides by -1, and I get x equals -9. That's my final answer. So if they give me 2 pieces of information, I can figure out the third piece of information just by using this formula over here. Okay, let's look at the last one. All right, so number 5 says, suppose y varies inversely as x, find k when x equals 4 and y equals 10. What is y when x equals 5? Okay, so this is number 5. We're going to start off by supposing that y varies inversely as x. So I need my inverse equation. Y equals k over x. The next thing I want to do is I want to figure out what k is. When x equals 4, so I'm going to underline the x equals 4, and I'm going to underline the y equals 10. Those are the numbers that I'm going to plug in first. So I know that y is 10, and I know that x equals 4. So now to get k by itself, how would I do that? Well, since 4 is in the denominator, I would multiply both sides by 4. So what that's going to do is, once you multiply both sides by 4, the 4 times 10 is going to give you a 40. And on the right side, the 4s are going to cancel out, just leaving you with k. So that's your answer. So we know that k is going to be 40 for this question. But then it asks a secondary question at the end, right? What is y when x equals 5? Now, I already know that we're using inverse variation. So that formula that we used on the left side, I'm just going to copy that over. I know that y equals k over x. It tells me that x is 5, so I'm going to plug that in. So y is going to equal k over 5. And then that last piece of information that I need to find out what y is k. Now, I know from here that k was 40. So I'm going to plug that in for k up here. So I'm going to get y equals 40 divided by 5. I plug in the 40, and 40 divided by 5 is 8. So that's the answer for the second question. Y equals 8. So for any one of these questions, you're starting off with a formula and you're plugging in two pieces of information to find the third piece of information. And you can do that with y, you can do that with k, and you can do that with x.